Hello everyone, this is Engineer Noor Khan, student of Electrical Engineering Department, Sakhar IBA University. The purpose of this video is to explain our final year project work that titles Conversion of a Petrol-Based Motorcycle to a Hybrid Electric Motorcycle. Along with me, two other students have worked in this project, Engineer Khalid Hussain and Engineer Muhammad Waqas. They both have really put a lot of effort into this project to make it successful and to make a fully functional prototype of hybrid electric motorcycle at the end. This FIP work is supervised by Dr. Qasim Ali, and we are really thankful for his continuous support throughout this final year project work. Well, the outline of this video presentation is like this. We will begin with a short introduction of hybrid electric motorcycle. Then we'll see some of the e-bike manufacturers in Pakistan. Then there will be a problem statement that why there is need of shift our focus from conventional motorcycles to hybrid electric motorcycles. Then we will see a literature review in which we will discuss some of the contributions made by other researchers in this area. Then we will see aims and objectives of this FIP work, and there will be results and discussion, and also there will be some limitations and recommendations for those who want to continue this work in future. Also, there will be a conclusion, and at the end there will be references. Well, so what actually is a hybrid motorcycles? Hybrid electric motorcycle is a type of motorcycle that combines two methods of propulsion. It can be the internal combustion engine plus batteries, or it can be internal combustion engine plus solar. So in our project, what we are going to do is basically we are going to design a motorcycle that combines the fuel mode as well as electric mode just in single motorcycle. Here in this picture, you can see that BLDC motor, which is placed in the back wheel. There are the batteries and there is a controller. So the controller will drive the BLDC motor. So in this mode, the bike will operate in electric, and there is the engine and there is the fuel tank. Fuel tank will supply the fuel to engine, and the bike will operate in fuel mode. So this bike is basically a combination of both electric mode and fuel mode. So this is the simple purpose of our FIP work. If you look at basically some of the bike manufacturers, then there is the most popular one, which is Jolta. There is the other company named MS Group of Industries. They're making an e-bike named MS Jaguar, and these bikes are also quite popular in Pakistan. Then there is Ride Star, Park Zone Electric, Road King. So these companies are making electric bikes in Pakistan. And if you look at basically the problem statement, then statistics shows that all around the globe, there are more than 600 million bikes which are currently in use. If you look at specifically within Pakistan, then there are basically more than 15 million bikes which are in use, currently in Pakistan. So the electric bikes are almost everywhere. And if you look at the global CO2 emissions made by these conventional motorcycles, then conventional motorcycles contribute for 14% of global CO2 emissions. And if you look at the Pakistan, the fuel price is increasing day by day, and the petrol price is around 275 right now, and it is fluctuating very frequently. And it is not affordable for most of the people to have motorcycle at their home and to purchase the expensive fuel. Also, the conventional motorcycles have higher maintenance cost, and their oil and clutches, oil need to be replaced after certain time. The gearboxes and clutches need to be properly maintained. According to United Nations, if we can shift to 90% of electric vehicles by 2030, then we can reduce the carbon footprints up to 11 billion tons by 2050. Here's the literature review section. There is a lot of research done by other researchers in this area. Here is one paper from IEEE Explore, in which the researchers basically show they have implemented basically a parallel hybrid mode on a conventional petrol-based motorcycle. And what they found is basically the parallel hybrid mode is more efficient than the conventional motorcycles. And these motorcycles, basically hybrid electric motorcycles, can give us greater efficiency as compared to the conventional motorcycles. On the right side here, you can see a picture which shows basically the electric and fuel mode together. Here, this is basically charger, this is battery and motor. So this section is of electric bike and this section is of fuel bike. So if both actually operate simultaneously, then this type of topology or configurations, what do we call, is basically parallel hybrid mode. Here are some other pictures from a few other research papers in which the researchers have worked on similar, some sort of, similar projects, like they have implemented parallel hybrid mode and they have tested it over in different environment conditions. And what they found is, again, the hybrid electric hybrid electric motorcycles are more efficient, they are reliable, and they can reduce, they have less, CO2 emissions. The ends and objectives of this FIP work are conversion of a fuel-based bike to an electric bike to reduce overall fuel consumption and exhaust emissions. Second objective we had in this project is digital speed and battery charge level monitoring system, implementation of an easy switching mechanism between electric and petrol mode. In next few slides, we will see that how we have achieved these objectives. Here's the methodology. As I mentioned before, that the hybrid electric motorcycle operate in two modes. One is electric and one is fuel. On the left side, if the switch position is at 1, then the bike will operate in electric mode, and if the switch is at position 2, then the bike will operate in fuel mode. So if you look at basically this section, then in electric mode, what happens is basically the motor controller drives the BLDC motor, and depending upon basically the input from the throttle. So if you are providing, you can control the speed of BLDC motor using this throttle, and this battery status, speed, and other indications can be shown, on the display that we are using in this project. Then the BLDC motor, which is placed in the back wheel, it will power the bike in electric mode. If you look at basically this section, then this is for the fuel mode, in which what happens is basically the fuel tank provides fuel to the combustion engine, and then from combustion engine actually drives the motor. So this is for the fuel mode. These are the components that we have used in this project, in which the first is basically 1 kilowatt BLDC motor that we are using. Then there is motor driver, throttle, digital display. We are using a breaker to provide protection in case of overloading or in case of any short circuit. And then we are using basically a 3-mode switch to implement, to achieve basically our third objective, which is, regarding an easy switching mechanism implementation. Then there we have used a harness wire to make the connections between motor driver, controller, and controller, battery, and BLDC motor. Then there is battery bank, and we also used a stain to test the BLDC motor in lab. Then there is petrol-based motorcycle. So when we started this FIP work, the first task was to test the BLDC motor in the lab. So the RPMs of this BLDC motor are quite high, so we can't hold it actually in our hands. So what we did is we made a frame to hold the BLDC motor, which is shown in this picture. So after placing the BLDC motor in this frame, we tested the motor in lab. So here in this picture, you can see that we used a 5 set of batteries, each of 12 volt. So together we were getting around 60 volt total terminal voltages. And we then used a digital measuring unit to measure the output power, current, and voltages. So we have connected we have made this experimental setup in the lab. And here's a short video which shows the readings that we obtained while operating basically the BLDC motor in the lab. Here you can see the voltage, power, and all the parameters. Basically, we measured these parameters using the digital measuring unit. Here's a table which shows a comparative analysis of what we obtained actually after operating basically BLDC motor at 48 volt and 60 volt. We tested the BLDC motor at these 2 voltages, and what we found is basically at the 48 volt, the output voltage or peak to peak voltage of the controller is 25 to 27, and at 60 volt it is 34 to 36. If you look at basically the current, then the current when we operated the BLDC motor at lower voltages, what we found is basically high current flows in the wires, and when we operate the BLDC motor at 60 volt, then the current drawn by BLDC motor is comparatively less. Then there is basically power and RPM. RPM is around 400 to 500. We didn't operated the BLDC motor at basically full throttle, but we were getting around maximum of 600 RPMs in our case. Here is a So this video was just for testing the BLDC motor at load condition. What we did is basically we initially tested the BLDC motor at no load condition, and we obtained basically the values of for the power, RPM, and current when we operated BLDC motor at 48 volt, and after that we operated it at 60 volt, and after that we connected a load with the BLDC motor and we tested it again. So after conducting all these tests, what we found is basically if we operate the BLDC motor at 60 volt, then the current flow will be lesser, and then there will be, of course, lower I square R losses. So after conducting all these tests, we came to conclusion that we should operate the BLDC motor at 60 volt rather than 48 volt. This is a picture of digital display that we have used in this project. This is a digital display from iBike, in which we have option to operate it at either 60 volt or 48 volt. As we are using 60 volt in this project, so we will be connecting this pin. So by connecting this pin, this display will work at 60 volt. Here's another video which shows some of the tests that we conducted in the lab using this digital display. Here you can see that the battery level, which is shown over here, the voltage of the batteries, and this is the speed of the BLDC motor. Here's another video. Here in this video, you can see that the speed is increasing, and the terminal voltages are around 52 volts in this case. So the previous video basically shows a successful operation of BLDC motor in the lab. So we tested it like this. After conducting all these tests in the lab, what we another task was to place the BLDC motor in the motorcycle. So for that, what we did is basically we placed this chain disc on the one plate of BLDC motor. We made 4 holes, and then we placed this disc so that it can be placed in the back wheel. We will further discuss in next few slides that how we have placed this wheel in the back side, how we place this actually in the BLDC motor. These modifications that we have made in BLDC motor actually. Here are the connections of this motor driver, in which here we have, this is a throttle pin. Here is motor connections, 3-man motor connections. Here is the Hall sensor. The purpose of Hall sensor is simply to detect the rotor position. So depending upon the data from the Hall sensor, the controller actually switches the position direction of current to energize particular poles of this rotor to maintain a continuous rotation. Here is the battery connection, and here is the brake pin. So the purpose of this brake pin is simply to let the controller know that whenever the brake is pressed, the controller will automatically disconnect this BLDC motor. Because what happens is basically while running the motor, if you press the brake, then what happens is the motor will be in overload state. So to avoid the overloading in such conditions, we need to disconnect BLDC motor while pressing the brake. So it is done by using this pin, which is available in the motor controller. So here are some modifications that we have made in the motor throttle. We have actually combined both the throttles in one. This throttle actually works both in electric mode as well as in fuel mode. So here is how we achieved our third objective, which is about implementation of easy switching mechanism. So here 60 volt supply plus ignition wire which goes into 3 position switch. If the switch will be in position 1, then the bike will be in off state. If the switch will be in position 2, then motor will be activated and 60 volt will be supplied to display. So display will actually indicate the speed and battery status and left right indications, and motor driver will then drives the BLDC motor. In third condition, what happens is the motorcycle will operate in fuel mode, and in fuel mode the ignition wire will be connected with the fuel engine, and the engine will just work like a conventional fuel-based motorcycle. So here the purpose of diode is simply to make sure that in third mode, which is in third P3, the motor to block basically the voltages from flowing in backward direction, to block actually flow of current in the backward direction from here in the position third, when the switch will be in position third. So this will stop the BLDC, the motor driver from operating BLDC motor in third position. So the 60 volt supply will just goes to here, and in third mode the display will show the speed and battery status and other indications, but it will not operate this motor controller. So only fuel mode will be operated in the third position, and in second position electric mode will be operated, and in position 1 the bike will not start, it will be switched off. So here's a short demonstration after connecting all the components, after placing all the components on the bike. We tested it and it perfectly worked. Here's another picture showing here we have placed basically the digital display, and here we have placed the BLDC motor in the back wheel. Here we have placed a socket. The purpose of this socket is to connect the batteries. Actually, we had 5 battery pack, which was quite heavy in weight. This picture is the one in which we have not mentioned actually the battery bank. We have actually placed a battery bank in the back side. So from the battery bank, what we can do is we can simply supply the voltages using the socket. So simply by using this socket we can supply the power to the controller, but in this picture we have not mentioned the batteries. So here are basically limitations and recommendations. Due to the presence of fuel engine, the weight of overall motorcycle is quite high. So in future work, what other researchers can do is basically they can work to reduce overall weight. They can use a lighter battery. They can use they can reduce the weight of engine. So that will actually increase overall efficiency of the motorcycle. And moreover, a system to calculate the miles traveled based on the battery status and fuel in the tank can be implemented, which gives the rider an idea of how long bike can run before it runs out of fuel. So such kind of system can be implemented in this motorcycle to make it more attractive and user friendly. So in conclusion, in this project, what we have done is we have made a motorcycle that operates both on fuel as well as on electric mode. And we have used 1 kilowatt BLDC motor. We have used a motor driver from Jolta, and we have placed all the components on the bike and we tested it successfully. So after placing all the components on the motorcycle, we found that it works properly, and we can control the speed of BLDC motor using the throttle that we have placed, as I discussed before as well, that we have combined both the throttles in one. So the throttle was properly working, the switching mechanism was properly working, and we then tested the bike under different environment conditions, and it was properly working. So this is a perfect model of hybrid electric motorcycle that can reduce the exhaust emission. It can help to also reduce the fuel consumption. These are the references from where we have taken help